Okay, hey, we are on day 3 of section 2.2, and today we're going to talk about tangent lines and writing equations for the tangent line. So, a little bit of calculator work today too, so if you have your calculator, that will be handy as well. Find the slope at the given point. Numerical derivatives, we will be evaluating the derivative at a particular point is what that means, that will actually get a numeric value. So there is a derived feature in your calculator that we're going to use to confirm our results. There's a couple ways that you can access that. One is to use the alpha key, and the alpha key, of course, is this green key here. And go to the window and hit option 3, or you could use math and then option number 8. If you have a TI-83, it's a little bit different. See me, I can help you get that put in because you do have to use some commas in your work. Okay, so problem number 32. We have, we want to get the derivative, and so f prime of t would equal. You know what, before I even do f prime, I think I'm going to kick that back a notch, and let's do a rewrite of this function. So I'd have 3/5 t to the negative 1. Now let's do the derivative. F prime of t is equal to, the derivative of 3 is 0. The negative 1 will come down and multiply, giving us negative 3/5 times negative 1, t raised to the negative 1 minus 1, because we reduce the power, don't we? F prime of t would equal, negative times negative would be positive 3/5 t to the negative 2, which we could see as 3/5 and t squared in the bottom. Now, what is the slope of this equation when we are at the location of 3/5, comma 2? Well, right now all I need to do is plug in my t value. I guess this would be a t value up here instead of x. Our independent variable is t here. Now let's plug it in. So I could write that I have f prime of 3/5, because that's where I'm going to evaluate it, and I plug it in, I can have 3/5 of 3/5 squared. That makes 3, 5, 9 over 25. 5 goes into 25 5 times, and then I could turn this, simplify this yet again. Right now we're sitting with 3/9/5. Dividing by a fraction is like multiplying by its reciprocal. So I'm going to get 15/9. Now, can the calculator do this? Well, yes, it can. So to use your calculator to do this, like I said before, you can hit the alpha, the window button. That gets me a quick short menu. Some of the things are contained in the math menu as well. I'm going to go to option 3 where I do the derivative function. I want x variable, and then I need to key my function, and the function was 3 minus, I'm going to build a fraction, so I'm going to go alpha y equals enter and get a fraction built, 3/5x. And then evaluating this at, what did we evaluate it at? We evaluated it at 3/5. So 3/5 is what's going to go in my spot right there. Hit enter, and there is my answer of 1.666, 1.667 rounded, or 1 2/3. Find the slope at the given point. So the first thing we're going to want to do is probably simplify this function, because I don't know how to do the derivative when I have a little bit of extra stuff. It's not just simply x being squared, but it's 5 minus x being squared. So let's simplify it by foiling out or squaring. So it's going to be 5 minus x times 5 minus x. That's what it means to square. That's going to be 3 times 5 is 25. I'd have a negative 5x, another negative 5x, making negative 10x for the middle term. Last times last will pick up a positive x squared. Let's distribute our 3. We're at 75 minus 30x plus 3x squared. That is f of x. Now, to take the derivative of that, I do f prime of x. The derivative of the constant is 0. This has a power of 1, so that's going to be a negative 30. X to the 0. X to the 0 is, of course, 1. And then plus 2 times 3 will give us 6x. And remember, I have to reduce, so I took the power, multiplied. Now I have to reduce the power by 1, which gives me 6x to the first. F prime of x is equal to negative 30 plus 6x. This is the derivative which states the slope of the tangent line. Notice that it is a general function because it has x's involved. So if you told me an x, I could tell you what the slope is at that particular x value. We are going to find it at x equals 4, right? So let's find the specific slope. The specific slope at x equals 4 would be take our derivative function and evaluate it at 4. So I'm going to have negative 30 plus 6. Replace this x with a 4. And I'm going to have negative 30 plus 24, which will give me negative 6. So I know my slope when x is 4, it is negative 6. Find the y value. The reason I want to find the y value is because I want to write the equation in y minus y1 equals the slope evaluated at the x value, x sub 1. So I'm going to use this point slope form of the equation to write the equation of my tangent line, which means I need a y value here. To find the y value, we go back to the original function. And our original function was f of x. So we're going to make this f of 4 equals 3. 5 minus 4, quantity squared. F of 4 is equal to 3 times 1, which gives us 3. I now know my ordered pair. It's 4, 3. And I join together these two important pieces of information. I'm going to join together the ordered pair along with the slope that was at 4. Writing the equation, I'm going to have y minus y value of 3 equals the slope, negative 6 times x minus, here's my x value, 4. And that gives us the equation of the tangent line at x equals 4. Very, very specific. So when x is 4, 1, 2, 3, 4, I'm right here. We have a tangent line in that region, right? So I could draw in my tangent line. That's not a real great drawing of it, but it definitely has a negative slope, doesn't it? And then it's going to go through the point 4, 3. So this tangent line is a little off. Maybe I can tilt it there, a little better. All right, next problem. Use the derive feature on your calculator to confirm your results. So let's do this one on the calculator. We'll just do it from the get-go. My goal is to write a point slope form of the equation. In order to do that, I need to find the derivative and calculate the slope at the point where x equals 1 in this case. And then I need also to get my y value out because I don't have it. I just have x equals 1. And then I can write it into y minus y1 equals the derivative times x minus x1. So let's get the calculator out and put in our equation. I'm going to go to my y equals screen to do this, and I'm going to clear off everything else I had. And my function is, I can see a fraction right away, so I'm going to build a fraction. 2 over. I can get an index for my radical by going in one of those submenus, or you could go even into the math menu, and it's available there. X raised to the third. And that is our function, isn't it? Let's hit zoom 6. We can graph that. And there we go. I'm going to sweep that off, close that for a moment. So what are we trying to do? Well, we're trying to find the equation of the tangent line when x is 1. So that tangent line would look like that, wouldn't it? Wonder what the equation is for it. Y minus y1 equals the slope, x minus x of 1. The slope we're going to get by doing the derivative at a particular point. Okay? So that's where we're headed. I'll sweep this off and let's continue on. So I have the function in my calculator. I want to calculate the slope. So f prime of 1 is equal to, we can use our calculator to do that. I'm going to go to my home screen. I'm going to get back to the beginning, hit clear, and I'm going to alpha, window, option 3, and start filling in. Now, I could key this function all over again, but I know that I had saved it in y1, so I'm just going to reference y1. I can do that by going alpha trace y1. Evaluating this at, wasn't it at 1? Yep, so we want to put it at 1. Okay, let's see, we were evaluating this at 1. And hit enter. And what does this give me? Well, it gives me the slope, negative 1.5 and 0, 0. Lots of zeros. Let's just make this then negative 1.5. You know, it's an estimation that's kind of going on, so it's negative 1.5. Now, I've got my slope. Got that. We need a y value. We have, let's find the y value. You know, and we could do this in the calculator, but for this one, it's pretty easy, isn't it? Y of 1 is going to be 2 and over the 4th root of 1 cubed. Well, 1 cubed is 1 and the 4th root of 1 is 1, so looks like our y value is 2. So we have this ordered pair of 1 comma 2, and I know my slope when I'm at x equals 1. We can write, step 4, we can write the equation of the tangent line. Y minus y1, which is a 2, equals the slope, 1.5, times x minus 1. And if it bothers you to have a decimal there, well, let's just bring it back to 3 over 2 for our slope. And there we go. So the calculator can be really helpful. The calculator can also draw in, like the picture I have there. If I go to my graph, I can ask it to draw it in. And what I can do there is this draw function. You can see it above the program key. So there's this draw function. Let's go second program. And see option 5 that says tangent, option 5. And I'm just going to key in a 1 for x equals 1. Notice that it changed in the bottom portion of my display. Hit enter, and it's going to draw in that tangent line. It also gives me the equation of it. And let's talk about that. The equation is showing up as negative 1.5 with all those zeros, x. Well, that is the slope that we had come out with, wasn't it? The version that the calculator spits out is y equals mx plus b. I'm sitting in a different format, but certainly we could do the math to get over to y equals mx plus b format, or the slope-intercept form. All right, the last question here says, determine the points, if any, at which the graph has horizontal tangent lines. Well, just looking at the shape of that W, or the quadratic, not quadratic, the quartic derivative degree here, We suspect that there are definitely horizontal tangent lines. As a matter of fact, I think you probably can spot them too. There has to be one there. It appears there's one there, and it appears that there has to be one there. So I think there's 3 spots that we should be able to find horizontal tangent lines. What is the nature of a horizontal line? Well, the nature is that the derivative of it is equal to 0. Would that be true for a horizontal line? We're going to use that knowledge to help us find these x values where this is happening, okay? So, where does it hit? Take the derivative, f prime of x equals 4 comes down, reduce the power by 1. 2 comes down, reduce the power by 1. Derivative of 2 is a 0. So we have our derivative function. Now, remember what we discussed? We thought this through and we said, you know what? If it's a horizontal line, it has a slope of 0. So we're going to take our derivative and set it equal to 0. So 0 is equal to 4x squared minus 16x. I can factor a 4 and an x out of there. That's just GCFing, right? And then I'm going to have x squared minus 4. Always go back and mentally double check, distribute back through. Yes, we get that term. Yes, we get that term. Okay, I did a good job of factoring. How do I get my solutions out of here? Well, I really have 2 things multiplied. And in order to get 0, either this could be 0 times some number over here, which would result in 0, or I could have some number in the first factor times 0 in my second factor, which also would give me 0. So I think you know the routine. Take each factor and set them equal to 0 and solve. That would make this 0. I could say x is equal to, or x squared is equal to 4. X is equal to plus or minus the square root of 4. Oh, then x is equal to plus or minus 2. I have the 3 spots that I was looking for. And do they correspond with what we thought? Yeah, I'd say so. Here's 2. I'm sorry, this would be x equals negative 2, and this would be x equals 2. And obviously this is right on the y-axis, so x is 0. And that's how we can find horizontal tangent lines. Take the derivative, set it equal to 0. There is a WebAssign out there to work on today. These problems, this is from section 2.2 in our textbook. Problem 38, 41, 37, 50, 58, and 60 are what those are similar to out of the textbook, and you'll be doing them on the online. So have a good day.